When we look at the visible light that comes from a distant star or galaxy, we see a continuous spectrum from violet at one end of the spectrum through to red at the longer wavelength end of the spectrum. So if we were to look at the wavelengths, they would be quite short here and they would be getting longer towards red. We also see that there are strange bands missing, and these missing wavelengths have been absorbed by the gas in the star's atmosphere, and they give us a clue as to what kind of elements are in the star. They're also very useful for us when it comes to an effect called redshift. We can mimic this effect in the laboratory by using a light source, shining it through some gas, and we have the spectra from violet to red with the missing wavelengths in, which are characteristic of, for example, hydrogen. When we compare that with the light that we see from a star or distant galaxy, well, most of the time, for most galaxies, we see that there is a shift in the wavelengths. You see that it's slightly shifted to the right, ever so slightly. In fact, that applies to all of the lines. So these lines give us a clue as to what's happened, because this wavelength has been stretched towards the red end of the spectrum. It's moved towards the red end of the spectrum. Why is that? Well, it's because this galaxy is flying away from us. And the Doppler effect means that its wavelengths have been stretched. Just like an ambulance passing by us and going away from us, and the sound wave's wavelength is stretched. We call this redshift. Redshift. And we call it redshift because the light has been shifted towards the red end of the spectrum. It doesn't mean it goes red, it just means it has stretched that wavelength and it's got more, it's got redder, if you like. What happens if that galaxy is coming towards us? Well, there aren't many galaxies where that happens. But when it does happen, we see the opposite, and that opposite is called blue shift. And if you look here, you can see that all of these lines have moved, to the left. Should do that in a different color. Let's do that in blue. So it's all moved towards the blue end of the spectrum, and so this is called blue shift. And that's when the galaxy or star is moving towards us very fast. But as I say, most of the galaxies are moving away from us, and that gives us evidence for a theory called the Big Bang theory, which we'll look at in the next flashcard. Basically means that the universe must be expanding if all of these galaxies are moving away. So let's take a look at this flashcard now and see if we can answer it. There is an observable increase in the wavelength of light from most distant galaxies. The further away the galaxies are, the greater the observed increase in wavelength. Now that's very interesting, and an astronomer called Hubble observed this. The further away the galaxies are, the greater the observed increase. And so what this means is, and so the faster they are moving away from us. This effect is called redshift. And it's called redshift because the wavelengths are stretched towards the red end of the spectrum. They don't become red, they're just increased towards the red end of the spectrum. And that's redshift, leading to a very important theory especially this part here, which tells us that the galaxies which are further away move faster away from us, and that theory is called the expanding universe and the Big Bang theory, which we'll look at next.